Good afternoon.
Good afternoon, sir.
Let's start in 2 or 3 minutes. So let us start the session now. So so we have seen this diagram. It represents the Hooks joint, okay, and it shows the path of arms of the cross of the hook joint. We have seen that theta is the input shaft angle, that is the rotation of driving shaft, and driven shaft rotation is shown by angle phi. Okay, so at any time the angle phi can be greater than theta, it can be less than theta, or it can be also equal to the theta, depends on value of theta. Okay, and kind of relation there is between theta and phi. Okay, so based on these projections, we have seen the relation between theta and phi as tan theta is equal to tan phi into cos alpha, where theta is input and phi is the output, that is the rotation angle of the driven shaft. Okay, so only 6 participants have joined. I How many students were present in last session of Johnson, sir?
Roll number 10.
Roll number 10.
Roll number 9 to 15.
Okay. So it was half batch with sir.
Yes, sir.
Got it. But only 6 participants means more than 50% are absent. I will now find out your attendance and will start calling the parents. You all please pass this message. Our Oditangshu is also not there. Tarun, Daniel, Oditangshu, who is our supposed to be in every lecture. Our CR is not there.
Yes, sir.
Okay. Okay. I will take some action. So we have seen this relation tan theta is equal to this. And now with the help of differentiation, we started to find a relation between input angular velocity and output angular velocity, that is omega and omega 1. Okay, so we differentiated this equation, then we simplified the trigonometric expression in this equation, and finally we reached to this relation between the speed of the driven shaft to the speed of driving shaft. Okay, where we can note down that alpha is the angle of inclination between the shafts. So two inclined shafts you are going to join, right? So what is the inclination between them? That is nothing but angle alpha. Okay, so far we have derived this formula. Okay, you can also write it like this: n1 upon n1 and n1 upon n, or omega 1 upon omega. You already know that omega is 2 pi n upon 16. Similarly, omega 1 is 2 pi n1 upon 16. So common terms will cancel out and you will get expression like this. Okay, so you note it down, this relation between output or driven shaft speed to the driving shaft speed. Note it down and let me know if done.
So this was done yesterday only.
Yes, yes. So have you noted it down?
Yes,
Yes,
sir.
sir.
Okay. So we already know now this, that n1, that is the speed of driven shaft, it is not constant. N1 is not constant. So it is CO constant. It varies. Okay. And sometimes n1 is greater, n1 is greater than n. Sometimes it is less than n. Okay. And sometimes it is equal to n. So we should find out what is the condition, what is the condition when speed of driven shaft is greater than speed of driving shaft, or at least the points where this speed will be maximum, n1 speed will be maximum. Okay, then the points in terms of the angle theta, at what angle theta the n1 should is having the minimum value, and at which angles, that is the value of theta, the n1 is equal to n. Okay, you can see that n1 is a function of here like cos square theta. Other terms are constant. Alpha is constant. Okay, so when theta will change, n1 will also change. Okay, so one by one we will see that. So let us see what are the maximum and minimum speed of the driven shaft. That is, what is the maximum value of n1. Okay, so we have already seen this relation, omega
Good
1.
afternoon, sir.
Yes, good afternoon. So class, Cleta ma'am is here to announce something about the projects. Okay, so I will hand over this session to her, then we will continue. Ma'am, you are
Thank you so
ready?
much, sir. Yes, yes.
Okay,
So
okay,
I'll
continue.
also require to share the screen. So if you
Yeah,
could,
I will allow you.
yes,
Mm,
yes. So good afternoon, everyone. I'm here.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon, guys. Good to meet all of you all. I think 5 students are absent. So I'll request one of you all to please convey this message to them so that they also understand the importance of what I am going to share with you now. Okay. So who's your CR?
He's absent.
Udit is absent.
So he's absent. So Tarun, you'll you'll form the message and forward it.
Okay, ma'am.
Yeah. Okay. So today I'm here to give you an overview of Innovex. Okay, Innovex is a B final year annual project exhibition that we hold every year where we exhibit our final year projects to everyone. We used to call people from out our industry personals, our alumni, parents. We used to take SETs, the first years, to go through all the projects. Unfortunately, in the last 2 years we were not able to hold this offline, that is in campus. We had a very good setting in campus. Junaid sir can share with you later of how we used to have it. The ground floor, we used to have this big stalls for mechanical projects. In the Mondani hall, we used to have projects displayed for COMS, IT and EXTC. It was a very grand occasion, but because of this pandemic we are not able to conduct it offline. Last year we conducted online on Moodle as a platform, wherein they were displayed. I am not sure if you all visited, anyone visited last year on Moodle? Any of you all visited? Yes, no, no also will do.
No, ma'am.
No, ma'am.
Okay, so good you didn't visit last year, because last year se much better hai this year. Okay, so I'm glad you didn't visit last year. So this year I want you to visit it. Okay, this year we have come on a new platform. It's a website. So in some time I will show you how to log on to this website and how you're going to register and how you're going to look at what you have to look at. So when you reach final year, okay, you are 15 students. Your 15 students, maybe around 3 to 4 groups will be formed. You will also be a part of the annual project exhibition. Your project will be exhibited to everyone. Okay, there will be an exhibition taking place. So what I want you to see, I want you to see what kind of work your final years are doing, what kind of the amount of efforts are required to be put into a project, that it looks like a complete project. Okay, many of you all have not yet met your guides. I will request each of you all to please meet your mini project guides. We have already given you the guides: Shri Prasad sir, Johnson sir, myself and Mahesh sir. My groups, I've been meeting them for the last 2 weeks, but the others, you are not meeting your guides yet. I think Johnson sir's group is meeting, but Shri Prasad sir's group and uh, Mahesh sir's group, you all have not met your guides. I will not give you all marks. I'm the project coordinator. Ultimately, marks goes through me. I will not give you marks if you're not going to work anything. You have to do something. You have to coordinate with your guides. Don't take these things lightly, guys. It's 25 term work plus 25 of oral practical. You're having Viva again. Last time we came to your last minute, I know, and that's why all of you all got marks. But this time you were already aware you were supposed to meet your guides. Okay, so ensure you're meeting them soon and start working on it, or else marks pay, I'll have to take a decision along with the HOD. Okay, and this is a very good thing that you are already started working on few things. This is additional alag from your subjects. You're going to learn something different, so please ensure you're doing that. So since you're already working on projects, see, next year also you have project, then final year. So finally, what kind of output? Okay, I have spoken to some of you second years. What I realized is you all feel just by learning the how a system works, that is all. But that's not all. You are going to be mechanical engineers. You have to learn to design. You are learn to do the modeling, do the analysis, come up with new innovations, and that's when the project will be complete. Not just by learning what is already there. You have to come up with new things. You have to learn new things, suggest new things, develop new things. That's why you are learning so many subjects. Okay, so this is going to be a very good platform where you can look at what is done by your seniors, learn from it, learn good things from it, and learn what is not to be done also. There are some projects who have not performed well, so you will see that aisa nahi karna hai. Okay, so please go through the Innovex exhibition. Now I will show you how to do it. Sir, I'm sharing my screen.
Yes, ma'am.
So first is you will log on to innovex.dbit.in. Innovex.dbit.in. You have to visit this website only tomorrow and day after tomorrow. Matlab you can't do it today. Okay, we will be circulating a message as well with all these steps so that you are aware about this. Okay, we will be circulating, but please remember, do not log in or register today. You can only do it from tomorrow. The exhibition is scheduled tomorrow and day after tomorrow, that is 30th April and 1st of May. Okay, so that message will be circulated to you. I will send it to Junaid sir. Junaid sir can forward it, or I will put it on the mini project group, either. So after going to innovex.dbit.in, you have to click on over here on login. Once you go on login, you can choose an account, whichever account. Now I'm already logged in. You choose your account, fill in the registration details as a student, SET, mechanical, fill that. And once you have logged in, this is how you will get the screen. This is how you will get the screen. Okay, so in this you will see Innovex 2021. What is Innovex 2021? It's all written over here, what I just explained to you all. Message from Nambiar ma'am, father, and myself. Down you have the winners of 2020. You will see these are the first prize winners of computer, IT, electronics, and mechanical department. What I want you all to do is, you can see here on the top, IT, COMS, EXTC, and MEC. I want you to go to MEC. Go to MEC. Once you go in MEC, you will see mechanical department and several projects. Look at all the projects. There are several projects which are displayed. These projects are under 3 categories. We normally have 4. Okay, so you will we normally have 5. Here you will see 4 categories: product development, research, community welfare, and environmental sustainability. So these are the different categories under which the projects are displayed. So you know that some of you all are working on Johnson sir's group is working on drone. So drone related projects will come under product development. My group is working on passive cooling system, that will come under sustainability. So like this you can go through different projects which are displayed under different categories. Okay, so we have here product development, here we have the research projects, here we have environmental sustainability and community welfare. Once you go here, so I'll click on the first one. So let's see. So this is a design and development of a soil sample collecting rover. Okay. So you will see that this part, if I click here, it will play the video of the project. Okay. You will able to go through that. On the right over here, you can see the names of the students. They are linked to their LinkedIn IDs. In case you want to ask any questions, you can click on their LinkedIn IDs. This is the abstract of the project, which you can read and understand what this project is about. If you go a little bit down, you will see there is a poster here. So if you click on the poster, you will see the poster is displayed. So you will be making like this kind of poster when you go in your final year as well. Over here, there is something called as rating: excellent, very good, good, average, poor. Now this is for you guys, SCs and Ts. You will have to rate the projects. Okay, excellent is 5, very good is 4, good is 3, average is 2, poor is 1. You have to rate the projects because we are having a critic award, a special award that will be awarded to the group which is getting the maximum rating. So each of you will rate the projects whichever you like: excellent, very good, good, poor. Rate them. You can even give your comments if what you liked in the project. You can give that comments here and submit. And once you do that, we will be getting all the data of the students who are rating the projects, and the award will go to the one who is getting the maximum rating. So this is one thing I want you all to do. Visit, rate the projects, understand what kind of projects are there, so that uh, you know what kind of project should be. Udit Dangshu, can you please mute yourself? Yes. So you will understand what kind of projects are there which are being done by your final year, and what kind of scope is expected from you when you reach final year. Okay. So tomorrow and if day after tomorrow, we are launching the project exhibition Innovex 2021 for all. I will request all of you all to please register and visit our website and the projects under mechanical. Provide the ratings, okay? Support your seniors, and hope that whoever you rate should win, okay? Now I'm open to any questions if you all want to ask. Any questions? No questions?
Ma'am.
No, ma'am.
Okay. Okay. So, CR, Udit
Yes, ma'am.
Tangshu. Yes, you have to ensure all are registering and visiting. Okay. Put a message. We will be circulating. You're in the CR's group, right?
No, ma'am.
You're not in the CR's group. Okay. I will post the message on mini project group, and I will send it across to Junaid sir. So once the message is put, each of you all will have to inform tomorrow that you have, so under your roll number underscore name, and you will write down registered. Okay, once you have registered, so you will be putting this on the group, mini project group. Okay, so that I know you all have registered, just for that sake. So Uditangshu, you'll have to ensure that all are dropping a message. Whoever does not put in, try to inform them and tell them to complete it.
Okay,
Okay.
ma'am. Yes, ma'am.
Yeah. So Junaid sir, there are no questions. I hope they've understood. Please share your experience of the Innovex that we used to have in campus with them whenever
Sure, sir.
you're free. Yes, sir.
Yes, yes, sir.
Yeah. Okay, sir. I'll take your leave. Sure, there are no questions. Can I leave?
Ma'am,
Yes, ma'am.
what about the funding, ma'am, on the
What funding
projects?
there? What is
Like
your complete
making
question?
the while making the projects, we require some kind of funding, right? Like,
Yes.
yeah. So it's from our pockets or it's from the college? Like,
No, college doesn't pay for anything. College doesn't pay for anything. If the groups get a funding from an industry or from an organization, so we sometimes get Mumbai University grant for certain projects, the faculty need to apply for it. Then there are student grants like ISHRE project grant. You have to apply, and if you get it, then you can use that money. Otherwise, if there is no external funding that is there, then it has to come from the students itself.
okay, ma'am. Thank you.
Yes, you're welcome. So that's a good question. Okay, this is a very good question you all asked. So at least you can start thinking about the funding aspect. You can contact some industries once you are in third year and ask them if you can do project under them. There are many industries who are ready to give funding for projects where they want research happening. Okay, so this is something that you will have to do at your end. So that's a very good question. Uditangshu. So good. Any other question anyone wants to ask? Please feel free to ask. I'm ready to answer any question related to projects. Yes, who's from Mahesh sir's group? Raise
Me,
your
ma'am.
hand. Yes,
Yes, ma'am.
Samuel and Motu were there na, with
In
you.
Norsa and Shubham.
I think they are not there today.
I spoke to Sir. Sir said that he will talk to us after 5:30 today.
Sure. Okay. Okay. I've also informed sir. So please proceed with it. Okay.
Yes, ma'am.
Yeah. Okay. What about Sri Prasad sir's group? Are they here? Sri Prasad sir's group.
Yes, ma'am.
Yes. Dennis, Uditangshu, and who are the other two?
Suraj.
Yes, ma'am.
Rahul.
Suraj
Rahul, ma'am.
and fourth one? Rahul. Okay. See, I've got a complaint from sir. Okay. Don't let me take up that matter. Please follow the instructions. He is your guide. Okay. And please do something in your project. We are having term work 25 marks and we are having oral practical. Okay. So I'll request each one of y'all who are here to please meet your guide and start working on your project.
Yes, ma'am.
Okay. Okay. Thank you. And similarly with Johnson sir's group as well. Just because I didn't call out your names doesn't mean you have to not do. Okay. That topic itself is your own idea. So I'm hoping that you contribute to it. Johnson sir's group. Who all are there?
Yes, ma'am.
Yes, Jerome, Nihali, and
Suraj Jatan is there and Sagar is there.
okay, they both are also there. Sagar, can you hear me?
Yes, ma'am.
Yes. And Suraj? Suraj.
Is absent.
Okay, fine. Thank you, Joel. Okay, so please meet your guides. Guys, start working and all the very best. I hope you will like our exhibition and participate in making it a success. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yes. Yes. Okay. Bye. Junaid sir, thank you so much for giving some time out of your practical. I will take your leave now.
Yes, ma'am. Welcome. Thank you very
Bye,
much.
sir. Yes.
Okay, so guys, this is very important. You know that you have to do some innovative project in your final year of engineering. So it is a best time for you to look at others projects, that what they have done, how they have done, how can you improve it, what should be your idea. Okay, so this way a link you can make. Okay, and you will be like always in that uh, mental state, that is means mindset will be there of doing a good project. Okay, so I will encourage you for attending it, the innovex thing which ma'am has explained very well. So let's get back to our point of syllabus, point of discussion. Okay, so please come back to this point. Okay, come out of that now and come back to this theoretical point. So we were discussing that omega 1 is varying with respect to theta, as it is obvious It is obvious from this expression or this expression that alpha is constant, omega is constant, but as theta will change between the values from 0 to 360 degree in one revolution, omega 1 will also change with that. So our first task is to find out maximum and minimum speed of driven shaft. Okay, means what I want to say you that what is the maximum value of omega 1? Omega 1 का maximum value. Like this I can give it suffix omega 1 maximum value. So for that you need to concentrate on this expression only. Okay, there are other conditions also, like as theta varies with omega 1 varies with theta, you can also take this derivative d for maximum condition or minimum condition, d omega 1 upon d theta should be equal to 0. It is the condition of maximum or minimum. Okay, but you don't need to differentiate so far. Just concentrate on this expression, that how omega 1 is depending on the value of cos square theta. Okay, so you can see that cos square theta is in the denominator, right? I mean, this omega into cos alpha is divided by something. If this division factor, if this factor which is in denominator is minimum, then value of omega 1 will be maximum. Agreed? Yes or no? What I am saying, that it is the expression to calculate the omega 1. Okay, now it got some denominator. This is the denominator. If this denominator is minimum, means obviously the value of omega 1 will be maximum. Correct or not? Okay, for example, see, it is 4 by 2, some value will come. Then you take, if you reduce the denominator, say 1, so value will be 4. If you reduce the denominator again, like if you reduce it by 0.5, say 0.5, say then value will be 8. Means if denominator is minimum, then ratio will be maximum. Okay, means omega 1 का value जो होगा वो maximum होगा. So what, up to what value the denominator can reduce? Okay, so here you can see that 1 is constant. Then as alpha is constant, sine square alpha is also constant. Okay, and whatever is the this factor is subtracted from this factor cos square theta sine square alpha, cos square theta sine square alpha is subtracted from 1. Okay, so if we subtract maximum value from 1, then this will become minimum value, this denominator which is shown in the square bracket. Are you getting what I want? I want square bracket to be minimum. Okay, so when it will be minimum, so this particular factor is subtracted from 1. If I could maximize this, if I could maximize this factor cos square theta, then maximum value will be subtracted from 1. Getting it or not?
Yes, sir.
Okay. So what is the maximum value of cos theta? Maximum value of cos theta is 1. Okay. And minimum value of cos theta is -1. Okay, so let us consider the maximum value of cos theta is 1. Okay, at what angle this value is 1? That is when theta is equal to 0, means cos 0 कितना होता है 1 होता है, and when theta is equal to 180 degree, even cos of 180 degree is also 1. So what will be your answer? 1 minus, now cos square theta is nothing but 1 minus sin square alpha. Okay, 1 minus sin square alpha you can write as cos square alpha, and this cos ka 1 power will get cancelled with this cos. So you will get the maximum value of omega 1 as omega 1 upon cos alpha, omega 1 upon cos alpha. And this value of omega 1 will be when theta will be equal to 0, means just when motion is starting, when just driving shaft is starting rotation, at that time the angular velocity of the driven shaft will be maximum, and again it becomes maximum when theta is equal to 180 degree, means when driving shaft completes the half revolution, at that time also value of angular velocity of driven shaft is this omega 1 upon cos alpha. Okay, so same will be explained. I hope that you are getting all this. If not, please ask me to repeat.
Understood, sir.
Okay, so same is explained here, that when theta is equal to 0 degree, 180 degree or 360 degree, at these points, at these angles,